Welcome to the program. Today we're going to cover lesson 1.1. Why Java? Why programming? Our learning objectives are on the screen, and I will call attention to those learning objectives when we reach the topic in which they are covered. So let's get started. Our first topic is language. Imagine that you are walking through a field and you come across a computer. Now imagine you try to start a conversation with this computer and you say, "Good day, Mr. Computer." The computer will just look at you confused. So instead, you try to give it a command, and that's something that the computer can understand and respond to. The reason this is because humans speak a spoken language, and spoken languages are mostly conversation based, and they have names like English and Mandarin and Hindi, which are the three most popular spoken languages according to some website I looked up. Computers, on the other hand, speak an interpreted language or a programming language, and those are more command based, and they have names like Python and C++ and Java, which are the three most popular programming languages according to a different website that I looked up. So, programming languages, they often look a lot like English words, and they are sometimes structured like English phrases, and they are interpreted similarly to their English counterparts. But you have to remember, they are not English. You are learning a second language. So, just to give you some comparison, the English language has 171,146 words, while the Java programming language only has 67 unique keywords. So, there are a lot less words that you need to learn when you're learning Java. So, that simplicity is going to make it easier to learn. However, the interpretation of the English language is very loose. For a while in the 80s, the word bad meant good. But on the other hand, the interpretation of the Java language is very strict. Bad always means bad. So that rigidity is going to make it harder to apply. So we want to introduce English words and phrases into our programming language, and we're going to need a way to differentiate the programming language from the human language. Our next topic is going to be a notional machine, and you might be asking, what is a notional machine? Have you ever looked at a computer and said to yourself, wow, he's so cool. I wonder what he's thinking? Well, a notional machine lets us look inside of a computer and see what's going on inside the computer at all times. So, what's going to happen is we are going to get some code and we are going to read and interpret that code just like we were the computer. So the computer has some memory in which it's going to store some information. And if we were able to look inside the computer and look inside the computer's memory, we'll see that the computer has two different sections for its memory. It has an area called stack memory and it has an area called heap memory. We'll also have a section for precedence. Now, precedence is going to tell us how the computer actually reads this code because remember, this is not English that we are reading Java code. And then we're also going to have a section for the console, and this is where the program will display information to the screen. So now that we have our notional machine set up, the first thing that we're going to do, I want you to just pause and read that code on the left and just see if you can figure out what it's doing. Okay, let's read and interpret it just like the computer would. Now we're just going to look at our rules of precedence for a second down here on the bottom left. When we evaluate our code, we start from the top and we read from top to bottom. When we get to a line of code, we're going to evaluate that line from left to right. So kind of just like how we read English. We start at the top of the page and we read from left to right and we work our way down. We're going to do the same thing with our code. So in our code, the first thing that we have on line one, we have a class named intro. Now, everything in Java needs to be inside of a class. A class is going to be a collection of all the code that we want to run. And so our class begins at this opening curly at the end of line 1, and it ends all the way at this closing curly on line 12. That's our block of code for our intro class. Now, intro is just the name that I made up for this class. When you make your own classes to collect your code, you can name your classes whatever you want. Let's move on to line 2. On line 2, we see void print stuff. Now, print stuff is a method. A method is also going to be a block of code, and it's going to contain an algorithm. An algorithm is just a series of steps or tasks that you want the computer to do. This block of code starts on line 2 with this opening curly, and it ends on line 11 with this closing curly. Now, you can name your methods whatever you want to name them. I decided to name this method print stuff because it's going to print stuff to the screen. When Java sees that we start a method, it's going to make some room in its stack memory for print stuff, and we'll be able to save stuff in memory. It's also going to make some room in heap memory for some other stuff, and we will look at heap memory in a later lesson. All right, let's start looking at that algorithm inside that print stuff method. On line 3 starts with a forward slash forward slash. What this is known as a comment. This is something that the computer just ignores. It's a way for a programmer to leave notes for themselves for later or for other programmers that might look at their code. So we're leaving a note. We're saying everything that you see after this point is going to be for outputting data to the screen. Moving on to line 4, we see system.out.print. Now, print is another method. It's not a method that we wrote, it's a method that somebody else wrote that we can use. And it also belongs to a class. It belongs to a class called system. Just like our print stuff method belongs to a class called intro. And we need to tell it what we want to print. So we can see inside the parentheses, we see Bruce. So we read this as system.out.print. Now you'll see a lot of periods when you are programming. Now we do not call those periods because they are not periods like you would see in the English language. They don't end a sentence, they don't end a thought. These connect things together in our programming language. So we call those dots. That's the dot operator. We read that as system.out.print. So everything that we've had so far has been Java code. Now you're going to look at it and say, well, no, this is English. I read it all as English. It looks like English. It uses English words and it's formatted like English, like we said, but this is all Java code. Now, the first bit of English that we get in here is the word Bruce. And so we need to differentiate that English from the rest of the Java code. And that's why we put Bruce inside double quotes. By doing that, we're creating something called a string literal. And that's telling Java that this is not code that you should really try to interpret. This is just English words and characters and phrases that I'm bringing into the code. So what this print method does, it's going to take this data that we put inside the parentheses, this argument, and it's going to display it to the screen, to the console. Remember, that's this area down here on the right. So when we get to our console, the cursor is sitting at the beginning of the first line. So that orange line that I drew, that's just where the cursor is. That's not something that you see, that's just an invisible marker on the screen so the computer knows where to start putting data. And we told it to put the word Bruce. And so that's what it's going to write to the screen. It's going to write the word Bruce. Now the cursor will be sitting right here after the E in Bruce. Anything that we tell it to print will show up right after that E in Bruce. Looking at line 5, we have another method from the system class. It's the print method again. And this time we're giving it the string literal of Wayne. So we're telling that, please print that to the screen because that's what print does. Now the cursor is right here next to the E, and that's where it will put that W. There will be no space. We didn't ask it to put a space. Wayne will show up right next to Bruce. And now the cursor will be waiting for us at the end of that line. Moving on to line 7, we have a slightly different method this time. It is still from that system class. It still belongs with this collection of other methods with the print method, but this time it is the print ln method. That ln is short for line. We're printing a line. We're not giving it any information inside the parentheses. We're not giving it any arguments or any additional data. So what the print line does, it will output whatever we put in the parentheses, but it will also move the cursor to a new line. That's what that ln says. It says move the cursor to the new line. So we asked it to print nothing. So that's what it'll do. It'll print nothing right where the cursor is at, and then it'll move the cursor to a new line. So that print line is taking this cursor and moving it down to there. Moving on to line 9, we're still working in the system class. This time we are using the print line again, just like we did before, and we're giving it the string literal Bruce like we did earlier. So that's going to go right here on the second line. That's where that cursor is. It's going to say Bruce. But since this is a print ln, it's going to move the cursor down to the third line. And so now the cursor will be at the third line instead of waiting at the end of the second line. That's what the print ln does. And then finally, we have on line 10, we have our last method call. We are calling print ln again. We are passing in Wayne again, and that's going to put Wayne on its own line. And since it is a print ln, it's going to move the cursor down to the fourth line. So anything that we print next will be waiting for us at the beginning of the fourth line. That's going to move us into our next topic, which is system methods. This is where we will cover one of our learning objectives, call system class methods to generate output to the console. Now you'll see this learning objective, it has some essential knowledge tied to it. I will point out where in this section that essential knowledge applies. So there are really three main steps in any program. You're going to get some data in. That's going to be your raw, unprocessed data. Then you're going to have your program process that data, turn it into something usable. And then finally, you need to get it out of the program so that you can see it. And so that's going to be your data out. You're going to clean it up and move it out of the program. Not every program will feature all three of these steps. And as we begin to learn the program, we're not going to include all three of these steps in our program. So here you see that program that we went through in our Notional machine. Take a look at it and decide which of these three steps do you think that we are using in this program. Now, we don't have data into this program anywhere. We're not really processing any data either. All we're doing is we're moving data out. We're moving data to the screen. So we just have that third step, that data out. And we use that print and println method to get that data out to the screen. So let's take a closer look to see how methods work. So imagine you are in school. When you're in school, you're going to have certain tasks that you need to perform throughout the day. And if you're going to ask for help with those tasks, you might want to let that person know a couple of things. You might want to let them know what class you need help with, what's the task you need help with, and what kind of data do you have to help you complete that task? So you might have a task for your math class in which you need to find the square root of something, and you might need to find the square root of 25. And if you can tell somebody that you need help with that, then they can then process that and give you an answer. So those tasks, they're going to be organized by class. And so you might have another task for your math class. You might need to find the bigger of a list of numbers. So you might say, okay, for my math class, I need to find the max number, and I have this list of numbers. I have 3.2 and 3.1. And as you go throughout your day, you will move to different classes, and you might go to your physics class and you might need to do something like calculate force, in which you then would have two inputs for that. Or you might go to your English class, in which you have to write an essay, and then this would not even be numerical data. This would then be like English, those string literals again. Whenever we hear that sound, that means that we are about to be introduced to a new type of coding statement. So whenever we learn a new type of statement, we're going to get a table like this that kind of breaks down that code statement for you, and it includes a box for you to write some notes or some observations. So we're going to learn what a method call statement is. Now, we said before, a method is just a pre-programmed block of code. So this is a statement to call or invoke that pre-programmed block of code or that method. Now we can see the general form in the bottom left of that table. We say what class. Remember, the class is just a collection of methods. And then we need to say what method we want to use. The method is that pre-programmed block of code that performs a task. And then inside parentheses, we give it a list of arguments. Arguments are additional data enclosed in parentheses and separated by commas passed into a method. We have some examples that we see in the examples box. We have from our system class, we have our print method. So we have system.out.print. And in this one, we do have an argument that we are passing in, and we're passing in the English word or string literal of Bruce. We also have our system.out.println, which we could pass in an argument. We don't need to pass in an argument to either print or println. We have one example where we are passing in an argument, one example when we are not passing in an argument. We also have some examples for the math class. So the collection is called math, and we are calling the square root method, and we are giving the number 25.0. We're also from the math class, we're calling max, and we're passing in a list of numbers, 3.2 and 3.1. Now, math is actually a class in Java. Physics, in the example we saw, it's not really a class in Java. English is not a class in Java, but math really is a class in Java, and we can really call these methods. Now, you might have noticed that both print and println belong to the system class, but it also has this dot out in the middle. This dot out is not a class, it's not a method, it's something else entirely that we need to use when we are using the system class. It is actually a variable that belongs to the system class, but it's not something that we are covering when we are learning method call statements. But it is something that we need to put in there when we are calling those methods from the system class. And that dot out doesn't appear with any other classes that we use. It doesn't appear in the math class. It's just something special and unique to that system class. So what we said is that these are pre-programmed blocks of code. So somewhere Java has the code for this max method written somewhere in a math class. And if we found it, it might look something like this. But we don't need to know how any of this works. That's not what the point of using a method is. The point of the method is the complete opposite, is that we can call these methods, we can ask for help to do these things, and we don't need to know how they are done. The programming language knows how they are done for us. So we don't even need to look at that. So when we are calling methods, there are really some things that we need to know. We need to know where that method is. What class is it in? And so we are calling system methods that belong in the system class. We also need to know what it's called, the name of it. We're using two different methods, the print method and the println method. what kind of data you might need to give it. Now with these two methods, we can give it no data or we can give it one piece of data. And what kind of data might it return? These methods don't return data back to us, they just put information on the screen, but we don't get any information back in our program. And you kind of need to have a general idea of what these methods do. So if you're calling them, you need to kind of have a general information of what it does, but you don't really need to know how it does it. So this leads us to our essential knowledge. System.out.print and system.out.println display information on the computer monitor. And system.out.println moves the cursor to a new line after the information has been displayed, while system.out.print does not. It keeps the cursor right at the end of that data. This is going to lead us into our last topic, which is string literals, where we are covering our learning objective, create string literals. So in the code section, we see that code that we have been working with this whole lesson. On the bottom right, we see the console, what would be displayed on the screen after this program is run. What we want to do is we want to identify the string literals. Now, the string literals, that's going to be those English words, phrases, symbols that we bring into the programming language. So on lines 4 and 5, we see the string literals right there highlighted in the yellow box. And on lines 9 and 10, we see the string literals there. Everything else not inside those highlighted yellow boxes, that's all Java code. Again, looks like English, structured like English, we kind of read it like English, but that's all Java code. The only English that we have are in those two yellow boxes. And did you ever notice that Bruce Wayne, he kind of has a common first name as a last name, and also his first name can also be used as a last name as well. I just noticed that right now. But we want to pay attention to that string literal part. That's what we're focusing on right now. And that's that green part of the code inside those double quotes. So a string literal is just a collection of characters enclosed in double quotes, which is our essential knowledge for this topic. A string literal is enclosed in double quotes. So if you ever made a letter bracelet, you can think of a string literal as that. You are literally putting letters on a string. So they could be letters, they could be characters, they could be numbers, and we are just putting them right next to each other on a string. So some examples, we have the word Bruce inside double quotes. That's a string literal. The word Wayne. We can intermix letters and numbers. So ABC 123 is also a string literal. We can use numbers and symbols. It doesn't even need to be an algebraic truth. We could say 1 plus 2 is equal to 4. We could just do all symbols. We could put in hello world, so we could put spaces in there to start creating phrases. We could put nothing in there. We could just open a quote and close a quote immediately, and that's called the empty string. We could have a string that's just a space, so an open quote, blank space, close quote. We can pretty much make anything a string literal. And so when the computer sees these, the computer knows that these are not commands to follow. It's just a way to bring English words and phrases into a program. And so, yes, I said we can pretty much make anything a string literal. So you're going to ask me, anything? Yes, anything can be a string literal as long as you put it in double quotes. And so then you're going to ask me, what about the Gettysburg Address? Can you make that a string literal? Sure, you put it in double quotes, it's a string literal. And then you're going to ask, what about Abe Lincoln? Can you make Abe Lincoln a string literal? Yes. If you put it in double quotes, even Abe Lincoln can be a string literal. The computer sees these and the computer says these are characters literally strung together. I don't really care what's inside. I just move the data where it needs to go. That's going to bring us to the end of our lesson. You should review how you feel about those learning objectives. read through those recap statements, hit me up with any questions or concerns that you have regarding this content. Join us in our next video and keep programming.